Okay, so this is working out problem number 9 on the Math Excel for section 6.2. And it says that according to a study done by a university student, the probability a randomly selected individual will not cover his or her mouth when sneezing is 0.267. It's very timely considering the COVID we've got going on right now. Suppose you sit on a bench at a mall and observe people's habits as they sneeze. What is the probability that among 18 randomly observed individuals, exactly 7 do not cover their mouth when sneezing? So this is the probability of x equals 7. So we know that when the problem says exactly, that means we go to our binomial PDF, not binomial CDF. All right. And in this case, we have 18 people. This is our N. This is our number of trials. Our probability, our P, is the 0.267. And then what we want to see occur, our number of successes, is our 7. So we're going to enter this in as 18.267. And also the x value is 7. Let me double check that probability, 0.267. Yes. Okay. And so we'll paste that on the home page, and we get 0.1010, which is where this number came from. 0.1010 is the probability that you would have exactly 7. Then for part B, what is the probability of 18 randomly observed individuals fewer than 3 do not cover their mouth when sneezing? And so this is the probability that x is less than 3. And so with this one, we said this is binomial PDF because of that word exactly. This one is going to be binomial CDF because it's the less than. And so this one is a little bit weird because remember with me that we're only doing discrete probabilities here. We're only doing whole numbers and integers. We're not doing continuous. So if I'm talking about less than 3 on a number line, right, we're talking about really 2 and below because we're not including 3. It's not equal to 3. And we can't include this stuff in between 2 and 3 because we're only using integers, whole numbers. We're not using any decimals or fractions. So when I go to enter this in my calculator, we're going to go back to the second and the bars button to get there. And then we're going this time to the binomial CDF. We're still doing 18 trials. Our probability is still 0.267, but this time our x value is going to start at 2. Remember we said we're not including 3 because it's not equal to 3, and so the next integer below that would be 2. So it's 2 and everything below is how this works. And 0.1039 is the number we get for that one. Remember, you're going to 4 decimal places, so make sure you get all 4 of those suckers. All right, then the next piece is a little bit backwards because they say, what would you be surprised, part C here, would you be surprised if after observing 18 individuals, fewer than half, so fewer than half would be the probability of less than 9, right? Covered their mouth when sneezing, and why? So when you look down at the problem more specifically in part C, we know we're finding the probability of the probability of less than 9, which we know is the binomial CDF, Again, we know that this number is always one less than that 9 because we're going everything less than 9. So the next lowest integer would be 8. And then, so this is what we're entering in our calculator. Let's go ahead and do that. So we're talking about second distribution down to that binomial CDF. We're talking about 18 trials, still 0.267, except for now our X value is 8. And we get 0.970, that would, 4 decimal places would round to 6. 0.9706 is where this number comes from, and also this number. The other part of this is a little bit tricky. It says you would not, is not, or is be surprised because the probability of observing fewer than half covering their mouth when sneezing is, number 2, this is part 1. Would or would not be surprised because part 2, it is or is not an unusual event. So remember with me back in our notes when we were talking about an unusual event, we said unusual events are 2 standard deviations away from the mean. So anything out here to the left and out here to the right, 2 standard deviation distances away. So we have to find our mean and our standard deviation. So let's go back to the formula. Well, I think we have a little cleaner version here. All right, so this is on the 6-2 notes, objective 3, page 1. We have our mean and our standard deviation formulas. So that's what we have here. We got to find what numbers are 2 standard deviations away, and then is our number, is it fit within those realms or not? So, excuse me. Here's our formula for the mean. It's just the expected value is what we call this sometimes. It's the number of trials times the probability. So we have 18 as our number of trials, 0.267. We would expect out of 18 people with a probability of 0.267 that 4.8 of those people would not cover their mouth when they sneeze. So then the standard deviation is the number of trials times the probability, which we just found that's 4.806, so I just put that back in there, times 1 minus the probability, so 1 minus 0.267, and then all of that square rooted, which came out to 1.8769. Okay, so now we have our standard deviation, now we have our mean, so now we need to look for 2 standard deviations away. Where does that land me? So here is the mean. Sorry, excuse all this stuff. That's the problem above. Okay, so here's our mean, which we said was 4.8. And so I know 1 standard deviation away would be 1.8. Now I am looking specifically to see if this number is an unusual number. Since 0.9706 is definitely less than 4.8, I'm going to subtract standard deviations and I'm not going to worry about these numbers over here where you add standard deviations. I'm not worried about 0.9706 being off to the right. So 4.8 minus 4.8 minus the 1.8 number, my standard deviation, and then that's only going to get me to 3. So I'm going to keep going. 2 standard deviations, 4.8 minus 2 of those 1.8s. That gets me to 1.05. So because that number 0.9706 rather, is way out here less than 1.05, right? On the x-axis, it's going to be farther to the left. Anything farther to the left of 2 standard deviations away is considered to be unusual. So, and same thing is true way out here to the right, 2 standard deviations away is unusual. So I would be surprised because it is an unusual number. So that is problem number 9.